What's up?
Yep.
What's up?
So now I'm making a video, and this is 7.6 inverse trig functions. I already hit play. Just so you know.
Hey guys.
Okay, trig functions versus inverse trig functions. A quick review. Okay, trig functions, sine of an angle outputs a ratio, input angle, output ratio, input angle, output ratio. Inverse functions, we're looking at the domain and the range being flipped. So on the arc sines or sines, I'm going to input ratio and output theta. Okay, so same thing here for cosine. Going to input ratio and output theta. And that's a true statement all the way through. This terminology right here might confuse you, arc sine, but it's just a different way of saying the same thing, sine inverse. It's the same function. So for the two, the domain of this is angles, and those can be in radians, or they can be in degrees. Which means, because they're inverse functions, this is going to be angles, degrees, radians. And then the range here is an output of the ratio from -1 to 1 for cosine and sine. And then for the other ones, there's a different one, but it's still a ratio. Okay. All right, we're going to run through a few examples real quick. We'll look at some difficult ones, and tomorrow in class we're going to go through the practice questions. So if I input -3 root 3 over 2, and I'm going to take the arc sine or the inverse sine of that, -3 over 2, sine is our y value. So I'm looking down here because I'm looking for -root 3 over 2. And that is here and here. Where's my unit circle? So on the unit circle, which hopefully you have memorized because I don't remember what they are, this is 3 pi over 2, and that's 9 pi over 12, 18 pi over 12. So this is going to be 20 pi over 12, and then 16 pi over 12, and then you can reduce those down. If you still need to use your unit circle, that's fine. Get mine out here for reference for you. But this is going to reduce to 5/3, and this one's going to reduce to 4/3. If you wanted, you could go around this circle an infinite number of times and come back to this point reoccurringly. But for this, we're going to say I'm just looking from pi to 2 pi. Arc cosine of 1 is the same thing. Where's the output of my original cosine 1? On the unit circle, it would be here only, so at 0 or 2 pi. One more, a little bit more difficult. You don't have to be that quiet. I've got theta is equal to the inverse sine of -8/15. So the first thing I'm going to do on these is I'm going to draw a quick sketch of where I'm looking at. The angle sine is negative, so I'm again looking down here in this world. So let's say here, I'm going to draw it this way. We've got 15 and -8. And then I'm going to use somebody else's calculator to calculate out what the value of this would be. So 15 squared minus 8 squared equals 161, square root that. So this is the square root of 161, and I don't know if that simplifies, but it doesn't look like it. It's not a very friendly looking number. So the cosine of that same angle, because I'm thinking about the unit circle, x is going to be negative, y is going to be negative, this is going to be positive. So the cosine of that angle, if it's in this quadrant, is negative root 161 over 15. Or if I'm looking over here in this angle, this quadrant, because that would also be negative 8/15, it could also be the same triangle reflected in this quadrant. The x value would be positive, so that'd be 161 positive. So root 161 over 15 would be the other value for the cosine of theta. So most of these questions will have a limitation on what quadrant we're looking in. One more, a little bit more difficult. We're going to look here at theta is equal to arctan of 3 plus arctan of 5/13. So we're going to make this live up here in the first quadrant so that everything can be positive. Okay. Arctan of 3, I'm saying here's my ratio of 3. I'm putting it into an inverse trig function. It's going to output an angle. That's why I have alpha there. Same thing here. I input ratio, I output angle. So the cosine of theta is what we're looking for here. The cosine of theta is going to be the cosine of alpha plus beta. Okay, so I'm going to come over here and make a visualization. Here's alpha. Arctan is 3, so opposite, adjacent, and then over here opposite is 5, adjacent is 13, and I can use my Pythagorean identities again here. 9 plus 1 gives us 10, square root it for our hypotenuse, and then I don't know, 169 plus 25 equals 194, so this is the square root of 194. And it doesn't look like 4 goes into it, so that would be the one I would look for to see if that simplifies. So now I'm going to have all of the information I need to be able to answer this. So the reason I put my little exclamation points here under the cosine of alpha plus beta is that's a compound identity. So we're going to go to our formula sheet and write down what the cosine of alpha plus beta is as a rule. It's cosine alpha cosine beta, and if it's add here, it's subtract here. Sine alpha sine beta. And then I can get all of the information I need for these values from this over here. Cosine of alpha is 3 over root 10 times cosine of beta. I'm sorry, 1 over root 10, that would be sine. Cosine of beta is 13 over root 194 minus sine, opposite hypotenuse, there we go, 3 root 10 times sine of beta, 5 over root 194. I'm going to simplify. 13 over root 1940, and then here 15 over root 1940. And common denominator says I can deal with those together. So I would say that is negative 2 over root 1940 is the cosine of theta, or the cosine of alpha plus beta. Okay. That's all. We'll go over these tomorrow in class.